Good. So we are here to talk about making your applications, your software manageable. My name is Osama Sajid. I am a program manager in the cloud infrastructure team. We deal with PowerShell, WMI, and my colleague.
I'm Wojtek Kozaczynski. I'm a principal as the software development engineer in the same group. We ready to go?
Yeah, I think
those slides are, guys, very impressive, so we'll just be squinting all the time.
Yeah.
So briefly, what we want to talk about is why make applications manageable, what it means to make them manageable, and then explain to you how we think you should make them manageable. It's very simple. This line at the bottom of the slide is important. Both of us come from the server management group. So our mindset is managing someone else's applications in the data center, in the cloud, and obviously, for that reason, manageability is to us quite important. So if you are interested in manageability of client applications, I don't know if we can help you much with that, but we'll try. Why does it matter to make applications manageable? I would suggest that we agree on a mindset that you build an application, we then get your application, and we manage that application in our environment. So you there, we here, and we have to make sure that whatever that application might be, some web application, some mission-critical application, what might be government application, whatever that application is, we have to make sure that it works the way you intended it to work.
And we here, when we say we make it manageable, it means that you write the software, and that software can now be managed from a broad range of things like System Center or third-party management applications, or your own in-house IT department which is managing it. But the base assumption here is the developer who wrote the application is not the one who's managing it, it's somebody else.
So our interpretation of the manageability is as we show here on this slide, which means that that application is capable of being managed. So now why? I'll argue about it, but I think it's relatively straightforward. That if we cannot manage your application, then two things happen. A, we spend a lot of time trying to figure out why it's not working and how to make it work, how to configure that application and all the other things, which increases my total cost of managing that application. And at the same time, your application, if it's not quite manageable, may spend more time being in some unknown state that we're trying to figure out why it's not working or not working the way you intended it rather than working. So that should be rather irrefutable argument. When we say manageable, one more point is that when we manage an application, we assume that we can manage that either locally, so we are on the same node on which this application works, but we can, in most cases, we are remote. We are managing your application from somewhere else, right? So that's the box at the bottom.
So think about like you have an HR application or your critical finance application that you're running either in the cloud or in-house, and you are in a critical phase, you have to do something, and that application all of a sudden is not behaving. So how those guys who are managing the production, how they go about making sure that, yeah, it is configured rightly, it's in the right state, and they can monitor what's going wrong, and they can then do mitigation of, that's what we mean by getting something managed. And as you can see, it's directly tied to the cost of ownership, availability, and uptime. So that's why we think it's very important to make your software, make your applications manageable.
To simplify the model, we suggest to think of manageability in 3 dimensions, which is one is that we have to be able to configure your application. Think of it that you expose some knobs and sliders, and we have to be able to get that remotely and set it up. Second, we need to be able to figure out in what state the application is. Some applications go through some involved states. All applications are definitely in 2 states. It's either up or down. But some applications actually go through other states. States have quite elaborate state machines. And then the third dimension is that when it's working, we should be able to see, and somebody made a quote earlier where you guys are gathering, that it's good to know what's going on in that application, and that's the monitoring. The application should be emitting information, events that we can look at, say, okay, that's in the past. Let's figure out what has happened. So our presentation will go through those three dimension slides, and we'll give you our bias, how we believe you should make them both configurable, how we can watch state of those applications, and then how you should make it monitorable. Let's go to the first part, which is
now that we know why it is important to make it manageable, thank you.
Right.
Then let's talk about how to make it manageable. And the answer to that from Windows Server perspective is Windows Management Framework. And why do we need a framework to make things manageable? So this is a thing, that's how the things would look like without a framework. At the bottom, you have things that are to be managed. So this is the stuff that you want to manage, like your disk storage or your own application or your servers like Exchange Server or SQL, your devices or the things that you as developers are writing out. You want them to be managed. At the top, these are the consumers, the IT pro who is managing something, or the IT developer or a solution developer who is consuming these things. So bottom, you have producers, top, you have consumers, and there is a total crisscross. Everything that comes up, if it comes up with a different way of being managed, different protocol, different schema, different API, then you can see that you add one more element at the bottom or at the top, the complexity just increases exponentially. So we think that the right way to make it manageable, to make the world manageable, is by adding a Windows Management Framework, and we will talk about that in a minute. But the basic idea is that all the producers, they write to a common abstraction, common set of APIs, common set of protocols, and the consumers consume it through those standards. And the word standard is important here because here Microsoft or we in server, we don't want to introduce new concepts or new protocols. We are going with what is already a standard for the community. So you can see at the bottom, for defining your model or your schemas, we are using SIM standard, SMIS standard. Both are very well established, understood. And at the middle layer, we have protocols. So when the client talks to manage these objects at the bottom, we are having WSMan protocol, the REST protocol, all industry standards, sorry about that. And we also have like our own, we would say, what is considered as a standard in Microsoft, PowerShell remoting protocol. At the top, this is the APIs through which all of this is consumed.
And the implication of that slide is that we can manage anybody who is instrumented in a standard way, and we can discover too, which is another thing. And by the way, when we say standard, that Microsoft is an active participant in the standardization group for management, which is called DMTF, for over a decade more. So it's nothing new, but the implication is that everything that's manageable looks to us the same. In other words, has the same interface. We talk to the same protocol. We can use different clients, and we'll show you how that looks like. Therefore, there is a uniformity.
So with this introduction, how many of you are actually familiar with SIM or DMTF or WMI? OK. So for those of you who don't know, I will give a quick introduction. So DMTF is a standard body. It came up with a set of standards. One of them is SIM. It's called Common Information Model. They also came up with a standard for the remoting protocol. It's called WSMan, Web Service for Management.
Web Services for Management.
Yeah, and we implemented that in Windows as SIM standard is implemented as WMI. So when we say WMI, it's basically an implementation of that SIM standard. Then the WSMan standard is implemented as WinRM in Windows, and we have added our extensions to it, which is like PSRP, but that's the basic idea. So what the result of this picture, as you can see, is that the consumers have a standard set of APIs to consume the stuff that is there at the bottom. So if you are, as the developer of the app, and are able to write to that standard or Windows Management Framework, then your consumers are able to use you without knowing any other new thing, without learning new things. And it's like if you write for example, you want to have a new storage device, you plug it in, or you have a new software, you write it into management framework, you get plugged into the ecosystem, and you get benefit from that. And that top-level consumer can be a System Center product like Operations Manager, which can now manage your application. So let's see how we will apply that principle, how we will apply this framework to a very simple picture. We will come back to this picture again and again, and rest of the demo we will be focusing, rest of this presentation, we will be focusing on demos. So more code, less slides. That's what we want to do with that session today. You have an application or you have a software that you want to make it manageable, and as we said, 3 aspects of manageability. One is the configuration, state, and monitoring. So we will see one by one how we will do that using Windows Management Framework or the technologies that are available as a part of that framework. Number one is how do you configure or how do you manage the state of something. And what we say is that you write a WMI provider to expose the configuration settings, the knobs, and the operations, which is a part of the state management. So you write a WMI provider to make that, to expose that. Excuse me. When I say WMI, a lot of people will say, "D, how many of you have actually written a WMI provider?" Just one person. So it is.
Okay, hold on to your seat.
Yeah. We got the feedback post Win7, why people are not writing WMI providers, why they are moving away to do other things, to make things manageable. We looked at that and we said, they're basically writing WMI provider is very complex. And this gentleman here, Ken, is nodding his head. So yeah, it is complex, and part of that complexity was COM itself. You had to learn a lot of COM and WMI internals to actually write a provider. So we looked at the amount of code that typically people write within Microsoft. If this is the size of their code for a provider, this is their business logic. The rest of it is just dealing with the infrastructure, making COM work, making WMI happy, or making sure that you have your ref counting correct, otherwise your provider hangs, and so on. We looked at it and we said we have to make it simple. And we invested in that. The other thing that was there was, that we heard was, yeah, we write WMI provider, but you know what? I still don't get the value of being standard because other things can't manage us. You say it's an implementation, but that thing has moved. DMTF has a better, higher version of schema we don't support. So we looked at all of that, and we came up with a new provider model. You will hear the name MI provider, V2 provider. All of that refers to the same model, the new API that we came up in Windows 8. In terms of flow, it's basically, you can think of it as a 4-step process. First, you design what your knobs or your operations are going to be. Then you do the development of that. You write code for that. You set it up. And then you use it. First step, designing your MOF or designing your interface. So MOF is a interface definition language. It is a standard from DMTF again. So we are using that standard. You use that to define what your entity looks like. This is like a class with properties, which is your knobs, and then you have your operations, which is the methods in that class. So you define that. We recommend that you, instead of inventing your own MOF, you look at DMTF standard MOFs, and they have a lot of schema already defined.
There's something which is called DMTF schema, which is about, right now it's almost 1,600 different classes that talk about everything in networking, storage, printers, system components, processes, processors, and everything else. So most likely, if you want to instrument something, then you will find the base class from which you can derive. So you don't have to invent it. It'll be even more standard.
And then if you don't find it there, you can do your custom MOF. It's not like if you are not in DMTF schema, then you are nowhere. No, you can define your custom MOF. You have the class. Then we wrote tools to make it easier for you to generate a skeleton code, because that was one of the pain points people had. I have to write too much code to get the basic stuff working. But here, You generate the code and your basic stuff is ready. At that point, you can compile it and it will work. You wouldn't have any logic implemented inside, but WMI will be able to load it and run it. Then you add your business logic, and this is the place where you would be spending most of your time, because you wouldn't be dealing with WMI or COM. It is a very simple model. And as we will see, that we have the ability to add even PowerShell-like semantics. If you are if you are familiar with PowerShell, you can actually write you can write a WMI provider which is like natively built for PowerShell. You compile it, all of your developers, you know how to do that. Then you register with WMI. Again, simplification of the process. WMI had some tools. People said the developers said it is complex. We made it easy. We have a new tool as a part of Windows 8 that registers your provider with WMI. Now WMI knows where to find your DLL and how to load that. Ready to go. Simplified process. And we will see that in code. So from this point onwards, I will be spending some time onto the code itself. And we can switch to 3. Yeah.
2 or 3? 2.
3.
3. 3. Yeah, 3.
Yeah, on 3. Oops.
And the examples we picked are exactly the same examples that you can find online. So.
Yeah, that's an important point. For this demo, we chose the sample which is available as part of the WMI SDK samples for Windows 8. Reason for that is it will give you a head start when you actually want to look into those samples and want to develop something for your scenario or for your specific need. These samples are available as part of SDK. So I'll go through that. Step number 1, we said design your MOF. And we also have a tool called SimIDE, which will help you browse through the schema and see what classes are available and generate your own MOF file from that. We wouldn't be going into the details because of time. But this is the MOF, simple MOF I defined. I'm saying that use the standard sim class called SimService. So I am here trying to manage services in Windows. Most of you wouldn't be writing that kind of a thing because this is part of the platform. This is part of Windows. But just to give you an example. So I derived the class.
But for us, we manage them.
Yeah. And and that's a good point, because in Windows 8, we added about 2,000 commandlets to make Windows itself manageable. So what we preach, we practice that as well. So we made it a requirement for all teams in server that if you are going to ship as part of server, you have to have a manageability story. Anything that can be done from GUI should be able to do from automation layer like PowerShell. So, and most of that implementation, I would say about 50 to 60% is done using WMI. So that's itself is an indication for us that the new API was really simple compared to the previous one. So I have this new class coming back to the demo.
Can you see the code in the back, or should we make it bigger? Yeah, they can see.
Okay. Yep. So we have this simple MOF. To generate the code from this, there is a tool, Convert MOF to Provider, which is available as part of the SDK. So you install SDK, you will get this tool. And this tool will, you just tell it where is your MOF file, and it will, for what classes you want to generate the code. You run that, and you get this code, all the code that you see here, that has been generated from that tool. Look at this. There are many files here, multiple files. You don't have to worry about any of that. It's all part of infrastructure.
But if you look at it, all the .h files are definitions of those objects that you derive from any objects, and there are some other things that have accessors to those objects. So you can look at them. It might be quite educational. Don't touch them. So you get fully strong typing. You get IntelliSense when you write your code. That's why we generated that. But there is only one file that you really need to touch.
So this is the file, like I'm writing code for managing Windows Service. So this is the class I will go and touch. And look at this code here. It doesn't have anything to do with WMI or COM. So the joke was that we had in the team was we have made it from complex to simplified, because now it just adheres to the SIM standard, from complex to simplify it, SIM with CIM.
And every time you see a prefix MI underscore, that's the new interface, stands for management infrastructure.
Yeah. So look at this class, and here I have a lot of all these methods. So these are my start and stop service, those two methods that I had added there. There are a bunch of other methods that are there which are part of the standard SIM. When you are writing a SIM class, there are some intrinsic methods that are assumed to be there. And like enumerate instances, delete an instance, create an instance. So the basic idea is that this is, if you implement those, then you don't have to add your own methods, again, making it simpler for the clients to consume your class. But you can decide not to implement that, and that's what is happening in most of the code here. You can see it says not supported. I will go to the...
So if the client pings that method, we'll just get back that it's not supported method.
So enumerate instances, which will give me a list of all the services and their state. This is the method that we implemented. I will go into the code here. Enumerate services. Again, this code here is dealing 100% with managing service. It's my business logic here. It has no details of COM or other thing. That all that detail has been abstracted out, hidden from you.
One more comment. You may have noticed that it's plain C is as plain as C is. For the reason that we'll explain later on, we actually have strong emphasis on portability to other platforms. We'll talk about it at the end, but that's why you see C. We made it even as simple as that.
So this is the code. So here, I want you to pay attention to these helper functions that you have. Windows service construct, set a property name like system creation class name. I wouldn't go into the details of what that specific property is, but the key message here is that when you are writing your code, all these MSFT, Windows service, and if I want to set a property, then I have these helper functions.
Services.
MSFT, window, there's an underscore at the top. So MSFT, Windows service, then you can do set. So these helper functions that you have here will help you write that code, and we generated those helper functions for you. So if we want to set a property, let's see status, for example, or the name, you have these helper functions. So again, it reduces the amount of code that you have to write to get started. These are all generated code for you, and you can use that.
If you have not written a provider before, it's hard to explain, but that was torturous to do that simple stuff before.
So all of this is generated code, and here I'm just focusing on getting a list of services and creating an instance and returning it back to WMI that gives it to the client eventually. So this code has, you can see, no WMI, no COM, and I will quickly show you where it goes. So all of the code that is required to deal with WMI and COM is actually hidden in this file. You don't have to touch it, but it's just for education purposes. You can go inside and see what it is doing. But for your implementation, this is the only file that you will be touching. Once you have this, you will compile, and then you are ready. You'll get a DLL. So WMI providers, by default, they are DLLs. So you are now ready to tell WMI to where this DLL is so that WMI can load it. For that, there is a tool shipping here called Register SIM Provider. This tool ships as part of Windows. It is available there. And earlier, we had a tool called MOFCOM. That was the way to tell WMI about where something is. And those who use MOFCOM said it is very complex. We changed that. Now it is like you directly register a DLL. You don't register the IDL file, which was the MOF. And that made a lot of things easier. You register that. You tell WMI where you want it to be, what's the name of this provider, and it is ready. Now, at this stage, your provider can be loaded in WMI. And to use this, I will just use the sample script which is available as a part of the SDK sample. So look at this commandlet here called get sim class, and now I'm using PowerShell. So if this is a commandlet shipping with Windows, that is coming back to the point that I made earlier, that we are shipping tools as a part of utilities, as a part of Windows, which will make it easier for your client applications to consume. Or if you are writing the client application, it will be easier for you to consume the stuff that others write. So this is an example. Yeah, you want to say something?
Yeah, this particular commandlet is important because that's actually a discovery commandlet. It discovers what has been registered with WMI. So we can find out your provider has implemented this class that you defined in IDL, them off. Now you register that. So now we can go back to WMI and discover what classes and their providers have been registered, and look at them, see what is their signature, and then we can start poking at them.
So we have, like, the next commandlet is get sim instance. Again, a utility commandlet to make it easier for people to talk to WMI and get data. So you run that, and this is the provider that I wrote in action. It is running. It is giving me a list of instances from WMI.
And you can run it either remotely or locally. There is a parameter that's not in the example, which is a computer. So,
yeah. So here, if I want to get it from a remote machine, I can do it using SimSession, or I can pass a computer name to tell it, go get it from a remote machine. And remotability is a very important aspect of management. As we said, if you make something which is only manageable locally, that doesn't go very far. So we have to make it remote-able. And if you are writing your software as per the WMF guidelines, Windows Management Framework guideline, like you write a WMI provider, then you don't have to worry about remotability. We will take care of that. So with just that much small code, you see that you got plugged into PowerShell, and then to the rest of the ecosystem, like System Center Operations Manager can call you, or Configuration Manager can call your component to make it more manageable. So there are other stuff here in the sample that I would skip. Let's look at the method that we had. So let's get an instance of a specific service. I want to do it for name like plug and play service. That's what I want to get. And again, we didn't write any code to enable filtering or query. WMI took care of that. So let's see what is here. $A, and is this service started? Yeah, it is started. So I can go and I want to invoke the method stop service to stop it. And I ran it with verbose. That's why I got additional messages. This verbose message, I can write code in my provider to actually send those verbose messages or rich errors. That is the case. So you can see tight integration with PowerShell, write code in C, in WMI, and get rich experience in PowerShell.
So this is our experience. If you do your job, that's what we see. We can now start you, stop you, whatever you expose.
So this is the part one of the demo. And so any questions so far on how to write a provider? Yeah. It would be good if you can use the mic so that others can hear you. Oops.
Is the mic on?
Okay.
Seems to be on.
Yeah.
Like around tooling, around to make like a .NET WM provider in C# or VBNet or anything like that?
So the question is how to write code, like management code in the native, not in native, but in the managed code, right?
Yeah,
so,
like if you writing a provider, but in C#.
Yeah, so we have a .NET API to write providers. So that's already there since Win 7. You can write it in managed code, but that code, again, as we said, it will not be portable. It will only work on Windows, right? And so, but if that is not, if you are only want to be in Windows, you can do it like that, or you can write a PowerShell commandlet, which is like just gives you the PowerShell experience. So that's also a possibility. I also know that folks in Microsoft, they actually created a .NET wrapper over the C interface, and they wrote their providers in System C#. That's like, you can do all of that stuff, but that requires a little bit more understanding of System C#.
So
but those are the possibilities.
The honest answer is that right now, no. We're working on it, but can't tell you much. But yes, that's a request that, as a matter of fact, what we're looking at is whether we can wrap it very quickly. If you write your provider in managed code, then whether we can wrap it quickly. But right now, we cannot give it to you. Oh yeah, no, we have fingers on the keyboard, but it's not in A.
So
we're not in Server 2012.
Let's take a step back, see where we started from. We wanted an application's state and configuration to be managed. So you can manage the state, you can manage the configuration. For example, if you wanted to change description of a service, I could have done that. That is left as an exercise and a homework. You go back, look at the SDK sample, and you can play with that. But if I have to poll to get the state of the services, anytime I have to poll the system to get the current status, that's not a very scalable way. All of you know that. That's a simple design principle. In my case, I was able to stop and start a service, but if I want to know what is the current state, I will have to poll. And the answer to that is, if we want to make it better, is that you write an event provider. In WMI's terminology, that's called an indication provider. So you write an indication provider. Indication is just a name of an event, so just a fancy name.
That's a name of a wrapper around an event.
Right.
Just not to confuse, well, or maybe to confuse everybody else. Indication is a packaging, standard packaging of whatever your event has happened. It says, okay, something happened. I'll give you a very well-structured object, which is called an indication, and it will have all the details about what has happened.
Yeah. So the idea is, application knows when something changes, and it can just throw an indication, an event, which tells what happened, and the consumers then take action on that. Again, the key is that if you have to write code where you worry about, oh, is anybody listening to event, or do you have any clients, that becomes like a very complex code. So the idea would be that you write code in a way which is like, doesn't even care about if there is a listener or not. You just throw the event, and the infrastructure takes care of delivering that event to the client, whoever that client is. So let's go to the code slide again. Sorry, to the demo. Yep. So the process remains the same. Start with a MOF, generate the code, write your business logic, register, compile, then register. Good to go. So let's look at the MOF.
Before we go, the difference, small difference between what's an indication and what's another class is that an indication is subscribable to. So if you implement an indication and we call your provider and you start actually sending that, the user experience is that he subscribes, gets a stream of those events coming rather than enumerate or start or stop. It's a pipeline. You subscribe to a pipeline of events generated by that provider. That's what indication is.
So here I want to raise an event whenever the state changes, like start and stop. Simplest of the state change model, right? You will have mostly more complex state machine to do that, but this is just to give you an example. I am deriving this class from a standard sim class called instant modification. Like whenever the instance is modified, send this event. So I'm using that instead of defining my own schema. I haven't added any more properties to it, but I could have done that. This class actually tells, as a part of this class definition, it tells there is a qualifier on that which says I am an indication class. I'm not a regular class. So when we generate the code for that, we get a slightly different kind of code. Again, a lot of code generated here to help you write the provider, but you don't have to look at.
Actually, there's only one method that you care about, which is if we call you, start calling us on the callback and pass to us your indications. That's all. It's only one method, which is post. You just post them, and we listen to them carefully, and if somebody subscribes to that, we just pass that to the subscriber, right? So you can, it's slightly heavy mechanism, but we can consume you from the same experience, PowerShell, C#, C, wherever. If you have, if there are some high-level events that deserves that kind of a treatment.
So you get to, like earlier we had seen there was enumerate instances, delete instance, the stuff to deal with an instance of a class. Here you have a different kind of methods here. disable indications, enable indications. WMI will call you to tell you that that just start listening, and then it will tell you now stop. So we do that, and let's just go to the code here. Here you can see that what we are doing is because the Windows services by itself don't raise an event or like that, an event that we can consume. So I started polling. We will be just talking about that in a minute, how to actually prevent that from happening. If you are writing like that kind of an application, how to prevent it. So what we are doing is Windows service, the entity that I'm managing is not raising event. So on the server itself, we are polling. And then the clients don't have to poll. So we are doing a polling locally, so the others don't have to poll. Okay? So there are other ways we could have written this sample, but
if you were just, you may feel like we're cheating a little bit, which is, if you were polling from a client, you would get all this traffic on the wire. You would have to look at what has happened and all the traffic back. Now we're just doing that very quickly on the server. So the abstraction for us is, we don't care how it happened, but we get an event. If you started, we get an event. If you stop, we get an event. So from us, from a management point of view, all we need to do is subscribe to that event and have some automation component that says, oop, if that stopped, this is what I need to do. That being that sending messages, my hair is on fire to some operator, or taking some constructive action, maybe try to restart you or move you to a different VM. But that's the idea.
Okay. So this code is all available as part of the SDK. So you can take a look at the details of the code. How we are doing that is just getting a list of services. After like 5 seconds, we take another snapshot, whatever's changed. We raise an event. We tell WMI by calling a method called post. We just tell WMI that there is something changed. So we will compile this DLL, go back here, and we can, to the demo script, and this is the DLL, service indication, and I register that in exactly the same way that I did earlier, and then I will be able to consume it from, something is wrong. Yeah. So first step, let's look at what classes got registered. So you can see my MSFT Windows service stopped and started. These two classes are there. These are the classes that I just wrote. And
those are indications. So in other words, inside an instance of the class is all the information about what service stopped, what service started, and all this other interesting gook.
So now to consume that, PowerShell has a commandlet. So you can call register sim indication event, and you will be able to. So I'm registering for this event called service stopped and service started. I'm registering for these two events. And I can wait for the service to start or stop, or I will just, for this demo, I will just force a start stop so that we can get that. And let's see, service is not started. I will start this service, and right now I'm calling the previous method, the start service method that I implemented in the previous demo. I called that, and now this will generate an event. I will get an event. So in PowerShell here, the experience is like this, that I can let PowerShell collect those events, that event stream that comes in, and I will then go to PowerShell and say, okay, get me the event. So this is the event that I got from the provider that we just wrote. The other way is that you can tell PowerShell this register sim indication event can take a script block. So you can pass a PowerShell script to it. So whenever that event occurs, PowerShell will not queue it, but it will just call your script block. So depending on what kind of the client script that you want to create, you will do that. For this demo, we are just doing that PowerShell will queue up the events that it receives, and then you can get it by using this commandlet. So if I look at what we just got, this is the object. So this object has two parameter like members, previous instance and source instance. You can look at what changed, and so previous instance was stopped, source instance is now running. So that's what we did. So that gives you an idea for writing just one piece of code which was enabling indications. We got that much value. We are running slightly behind on time, so I will skip one part of the demo which I had, which was about creating a richer PowerShell experience. For example, here, to consume the class that we created, we are using getSimInstance and setSimInstance, invoke sim method. But what if you wanted commandlets like start service, stop service, get service? So how do I create that? I wouldn't be doing that because we have to cover the rest of the demos. But if we have time in the end, we will come back and do it. Okay?
And then we'll be available after the presentation for as long as needed.
Oh yeah. So if you have more questions afterwards, we will have that. So
ask you there questions. Any questions
Okay.
about that part?
So as notifications are raised to WMI, the PowerShell's not consuming them, it's just viewing them, right? So that's available if I were running App Center or something, I can see those. Consuming those notifications doesn't make them unavailable for other apps, right?
So the question is, if PowerShell consumes notification, does it mean that other apps can't consume it?
Right.
Right. So no, it is still available to other apps.
Okay, so
Oh, yeah, there are two. I think there may be two questions. There may be multiple subscribers to the same event. So there are hundreds, and they all will get, WMI will figure out that these sessions subscribe and will push those events to the clients. Now, what the client does in this particular case, we use the standard PowerShell behavior, which just puts that into a variable, which is a global variable you can look. The other set of parameters on that subscription, which is, if you just do plain subscription, PowerShell by default will shove that into this, global variable. On the other hand, there's another set of parameters, which is an overload to that, which you can give it a script. So PowerShell then will run a script, and will pass that event to that script. So then you can do whatever.
as each event is raised, that event is passed as a parameter to the PowerShell script you specify.
That's exactly right.
Okay.
If you write the script, that's right. That's what we would call the automation. The other one that you can sort of have another script that peeks into what events have been. And by the way, this global variable, when you read an event from it, you don't preempt it. You have to simply say wipe out what's there. So think of it as sort of a persistent little buffer of events that you can always peek into.
So a quick recap before we go to the next set of demos is, first thing is, don't invent your own mechanism. Use what is there. If you want to expose knobs, use WMI instance provider. If you want to raise events for monitoring the state, use indications. Don't invent your own mechanism. Second message that we have here is that writing WMI providers is easy. If that is the thing that scared you in the past, it is now very easy, and there are other benefits that we will see at the end of this deck that we are not talking about right now. So there's one thing that we will hold. And the third thing is about if you write it for the Windows Management Framework using standards, you are ready to manage it from anywhere. System Center can manage you. Other client applications like other third-party monitoring applications can manage, or you can write your own applications. That's the key message. And WMI is now well integrated with PowerShell, so you don't have to worry about, if I write WMI, then I will have to write another set of commandlets for PowerShell. You can write rich experience for PowerShell using WMI. And although we didn't talk about the demo, it's available in the sample. Okay, go ahead.
Okay, so let's go now. So by now you probably have this feeling that the indications are heavyweight way of informing about something happened. It is. So those are the kind of a life cycle events that you would like to know that the application died or moved to some significant state. There's another question, which is how do you peek into an application's behavior and see what has happened inside of that application? And this is the right side of our diagram, which is the monitoring part. How many of you have used ETW, Event Tracing for Windows? How many? Hands up? Not too many.
5, yep.
Some? Okay. So because we're running short on time, my key messages are the same. If you need to trace, if you need to generate events from your application, so we can look into those events, we can hook to your application, log them somewhere and look in them, don't invent your own mechanism, use ETW. And ETW looks like this. For those that haven't used that or haven't looked at it in detail, it is built into the lowest level in Windows that you can think of. This is the kernel level functionality. On the left-hand side is your application. It actually cares about two things. One is that it's an API to write to ETW. And the other one is an API to register that I am alive. So in other words, when your application starts, says, hey, I am an event provider. And from that point on, if you start writing to this other event write API, and those APIs are native and they are also managed, then ETW now listens to you. Think of ETW as an event bus. It doesn't deliver those events until somebody asks for them. That's the right-hand side. So it can be our management application. It could be a tool, and I'll show you some of those tools. As soon as that tool says, hey, I want those events, and the identification of the provider is through a GUID. So it's, each provider, I'll show you that in a second, has a GUID. Say, I want the events from that provider. Then ETW starts pumping them. It starts storing them in its own buffer and then calling you on that callback. There's a number of standard right-hand side consumers, like if you've seen Event Viewer, it's one of those. If you've seen Logman, which is another utility, I'll show you is one of those. You can write your own and all this other stuff. But this is a lightweight mechanism. You can't make it any lighter. On write printf, that sort of stuff, it doesn't get, so your application just keeps on writing, and it doesn't care whether somebody listens. The extra cost is, we know it's like less than 1% of the entire performance. So you're writing, you don't care who listens. When we need to listen to you, we connect ourselves to you. We get the event, and we'll look at them, right? As I said, there's APIs for managed, unmanaged code, but just to show you how it works, we created we just created a little random event generator, and we gave it a personality. It is a frog. And why it's a frog, then I'll tell you a joke that led to the selection. But we asked that frog to every second make a decision whether it's to jump or eat a few flies or dive underwater, right? So the frog generates events, right? And so you can see we tell Kermit to jump. We're trying to figure out, we randomly generate a number, and Kermit decides whether to jump, and we randomly telling Kermit how far to jump, how many feet. Or we telling Kermit to eat number of flies, randomly generated flies, or we telling Kermit to dive underwater for that deep for that many seconds. So just little application. And we tell Kermit to keep on doing that if we start that guy.
So here we are just using it for a sample to generate events and a stream of events. In your application, you will have like real stuff that your application is going through. You will generate events for that.
We're trying to make it as simple as possible. Now, if you look at the method, so if we look at the method, there's this one line which says, generate jump event. And by the way, there's multiple mechanisms how you can instrument the application. What I'm showing you is one, which is available .NET 4.5. And the magic is in that class right here. If you look at that class, it inherits from system.diagnostic.tracing.event source. And that's the class.
Quick question. This event source is only available on 4.5 framework, not earlier?
This the example?
Yeah, for now the event source object. The event source,
This one?
yeah.
I'll give it to you after that.
No,
His question was,
Oh, I'm sorry?
Is it available in .NET 4?
4.5. Oh, sorry. Misunderstood the
so
question.
the question was, is this class, the event source, available
4.5.
in 4.5 only? And the answer is yes. It is not available in 4.0.
This is just an example. There are other APIs that are available way back. This is the simplest way to instrument. And I'm trying to convey the message. So the other way to instrument is that you define your events. Then there's a tool that generates, you link with this one and you write events. This is the simplest way. There are multiple ways to do that, right? And this is the class. And here is how the events are defined. So you fundamentally define your write event. You nest your write event in a method, and the magic is here. The magic is in this language attribute, and I just put a comma to show. So if you know ETW, there are all other parameters of event definition. So this is an event definition. So what I can do now, I can start the frog. So frog is running. Maybe it's not running yet. Oops, what the hell did I do? F8. So frog is running now. Nobody listens to the frog, but it's telling us what it's doing. Dives and eats. So now, if something happens and I have an application, then we need to somehow connect to that and get that information from it. So here is one of those utilities, which is a logman. And that particular command says, Mr. Logman, connect to that particular provider. And that GUID is the same GUID that it's in the code of this my application. So, by the way, when I started Frog, it registered itself through the magic of that class, registered itself from ETW. So ETW knows that the Frog is pumping the events, right? Now, Logman now will say, OK, I'd like to get those events. So now Logman, so Frog is jumping, eating flies, diving, coming up, and that sort of stuff. Logman is now logging the events, right? So now let's stop Logman. Let's see if the frog is still alive. A frog is still doing what frog is doing. Now I will stop that, the Logman. So imagine that the scenario is that I connected my probe to you. I got some behavior. Maybe I ran a test, connected Logman. Actually, that would be. I ran a test. Now I'll stop it. And then we have in this directory, now we have an ETL file, which is the log. Oops.
Yep.
So here is the file that we created. Now it's a question, how do I look into that file? There are multiple tools to look into that file. I'll start one, which actually is available. There are references to everything that is here in the slides. That's the tool, which is called PerViewer. You can find it, you can download it. And here is our frog. And here are all its events. So for example, let's see how many times it dove. Well, actually, it dove 5 seconds to the experiment and some change. It dove. Here it says, I have dived 10 feet for 4 seconds. That event was called with 2 arguments, which is depth 10 and time 4. So the meta point is that if you instrument your application with ETW, which is very simple, there are multiple interfaces, we have a host of ways to watch you. As a matter of fact, we can connect ourselves to you at real time, and with some gymnastics, we can pump it to PowerShell and that sort of stuff. But the point is, from us to you, don't invent stuff, right? So I'll go back to the presentation.
So let's look back at the scenario that I pictured earlier, that you have a critical application.
Just this point.
Yeah.
Sorry. This is my meta point, because we're running like 5 minutes and so we need to finish. If you want to do lightweight eventing, right? Indications are for life cycle events. You're dying. You change your state. You don't have resources. We have to give you resources, right? That's indications. This is something has gone wrong. We need to go and figure out what has happened, right? Don't invent your mechanisms. Don't use printfs and all this stuff, wasting your time. We are consuming those quite easy. So we've invested already. We are making more and more sophisticated tools by which we can analyze those traces real time and that sort of stuff. So you will see, as we move forward, quite a bit of progress with this. And I think I need to stop my frog.
Yeah, so I was saying that if you take it back to you have a mission critical application running in a data center or in your own in-house, something is going wrong. So let's take a step back. If you had made it manageable the way it was described, you have knobs available, you can monitor it, what it is doing, you can have detailed tracing available of what is going inside the application, and your the production team can look at that and say, this is exactly what is happening. They can send the log to you, the developer, or analyze it, take action to remediate the situation. It's a much more simpler life than like continuously trying to analyze a huge list of printf statements to see what's going wrong, right? So coming back to here, based on these demos, any questions so far? Yeah.
Application doesn't know who's listening to it. Application just squirting those events into ETW at very low cost. As a matter of fact, if the application cares, there's another API that we can, if you give us a callback, we can tell you if somebody's listening to you. So if generating an event is expensive and you would like to know whether somebody listens or not, we'll give us a callback, we'll tell you. But if those are cheap events, just write them. We just drop them on the floor. That was like in my diagram. We just drop them on the floor instantly. Don't worry about it. And there may be multiple listeners, and we can listen to you, and we've filtered and all this other stuff.
So far what we talked about was just for Windows. But what about non-Windows? There are a bunch of devices that are not running Windows. There is stuff that is in data centers that is running Linux, right? So what about that? If you are writing software for that, if you are writing software to manage a device or manage something on the Linux, how do you make that manageable? So the answer is open management infrastructure that we open sourced. And this is like for people who have known Microsoft for years, open source, Microsoft, what's going on? That's the reality. That's the new Microsoft. We have invested heavily in the standard space, and we think that to make this ecosystem successful, we have to invest on the non-Windows side as well. So it is available open source. It is, yeah.
So the meta point is that, for example, we go into someone and say, hey, you know what? We like your switch, your network switch. But we don't like the fact that it's managed in some other way. We don't want to write a special client and talk to you through a special protocol, right? And people say, yeah, so how would I make it manageable? And we say, hey, take the same standard. And people say, well, how do I do that? And we say, take our infrastructure. We'll give you the infrastructure. You write the same stuff. So if you are in that bubble, it's not negative. But if you actually play in our environment, but you're not Windows, then we say, and the answer is exactly the same. Minus ETW. ETW is Windows specific, but indications, classes, SIM, it's all standard.
Yeah, so there's a question there, yeah.
So, I mean, to what extent is Microsoft thoughtful with this? Is this mechanism used, for example, in Azure? Is it the way that services in Windows Server 2012 are instrumented? I mean, to what extent have you eaten your own dog food on this?
Oh, we are full of that dog food. Everything in Windows Server 2012 is instrumented. So Osama said we exposed more than 2,000 Windows management commandlets. Half of those commandlets, or more than half of those commandlets, are actually an interface to that because there are some legacy. So think of it that over 1,000 management commandlets is built this way. You said Azure. We're working with other. Osama can tell you we're working with other companies that when they gave us. There are things that like switches and storage. Storage is way ahead of everybody else. If you buy storage, they all manage through SIM, so storage is not a problem. We're trying to create an ecosystem that manages itself through the same set of APIs. We eat that dog food. You do.
Yeah. So here, if you are writing software for non-Windows, like devices or things that you are managing, the answer is use OMI. You can decide to build your own infrastructure, but it is available. It's fast, reliable. It is very small footprint. You can use that. And it has OMI and WMI have the same set of APIs for writing the providers. So you don't have to, again, learn a new thing. From the client side or the consumer side, same set of APIs, same protocols can be used to manage that. And if you are storage, then the protocol is not WSMAN. Then we talk SMIS because that's like a more advanced storage is way ahead of others. So we adopted that standard for managing storage. So that brings to the sort of end of this demo so far, and we are sort of almost on time. Yeah.
I think we said that number of times.
Yeah.
You want to repeat it?
It's same message. Write to standards. It is easy. We are trying to make it even easier in future releases. If you get plugged in to this ecosystem,
This is an important point. We're continuously investing in that infrastructure. We invested a lot in 2012 server. We continuously invest in those standards. That's why we keep on banging on it. Just use it.
So these are the resources that you can look at. The slide decks will be available, I think, with the build series. And don't forget to evaluate the session. Your feedback is very important to us. So thank you very much, and sorry for taking 30 seconds more. Thank you.
And we'll be available for as long as you need us.
Yep.
Yep.
If you have questions, we will be in that red brain box. Good. Thank you.